So how are carbonates important for metals exploration? Can we dive into that topic as well?
Sure. I mean, carbonates are the host rock for petroleum reservoirs. They can also be host rocks for the metals as well. We know what we know about them is that they have holes and they're good, well connected. And so a lot of ways that we study them are the same. And it doesn't matter whether we're searching for oil or metals, it's the particular environment where it's in. We need to understand how to look for them so that we can find these resources.
Yep, exactly. And the building blocks for a low carbon digitized economy are critical metals and base metals. I'll give you a few examples. So tungsten and rare earth elements, they're now on the critical minerals lists of the USA, the EU, and Canada. And copper is another metal which is crucial for electrical systems. And that's also on Canada's critical minerals list. So first of all, I'll talk to you a little bit about a type of carbonate rock that Jean mentioned before called skarn. And skarn is a type of rock which is formed when very hot waters, hundreds of Celsius, relating to volcanic systems, volcanoes, replace limestones and dollar stones like this. And they also carry metals in solution, and they deposit those metals into the skarn. So most of the tungsten that we've used for light bulbs for over a century have come from skarns, and they're often concentrated in North America and also in China. But skarns are also sources of copper and iron, gold, and zinc. The rare earth elements are a group of metals which, as I said before, we require them for permanent magnets in electric cars and wind turbines. It's like the transmission, the drivetrain between the wheels and the electricity generator. We also need rare earth elements for mobile phones and for our LCD screens on our laptops. And they get a lot of attention because China provides 60% of the world's rare earth elements, and it also holds about 30% of global reserves. And so a lot of stakeholders, countries, governments want to see a more diversified supply of rare earth elements from several different countries. So what we need to do is to go and find those in carbonatite rocks. They're quite an unusual and fascinating rock type. It's a magma from 100 kilometers deep in the Earth's mantle, except its composition is basically like salty chalk lava. And sometimes it comes to surface and dribbles out of these carbonatite volcanoes. There's one in Tanzania, which is recent. Otherwise, these sort of brine chalk magmas, they get trapped in the plumbing systems underneath volcanoes, and the rare earth elements get trapped with them. And what we want to do, therefore, is to try and find more of these carbonatite rock types with rare earth elements, hopefully in them as well. And so geophysics is going to be a vital way, a technique, to try and find carbonatites that host these rare earth elements using either aeroplanes, helicopters, or drones. What we want to do is to try and measure anomalies in the Earth's gravity or magnetic field, electromagnetic behavior, and also its radioactive behavior, because this is how we're going to find these carbonatite rock units. And it's quite interesting because in the 1950s, there was a lot of search for uranium around the world, and airborne geophysics surveys used radiometric tools. And because uranium and thorium behave the same way as rare earth elements in magmas, in hot fluids underground, that's how a lot of rare earth element deposits in Canada were discovered during the uranium exploration program. And I'll touch on a little bit on zinc and lead as well. These are very important industrial metals. And we also get a lot of them from carbonate rocks, from carbonate sedimentary platforms that form in the fallen basins of mountain belts. And there's a type of mineral deposit called Mississippi Valley type. And again, the metals are hosted in the fractures and in the cracks of the carbonate rocks, like you can see here. And I think these mineral deposits probably deserve a whole podcast for themselves. But what I'll do is I'll just touch on the fact that petroleum, lead, and zinc often move around together in the subsurface, which is really useful because it means that people looking for zinc and lead can use petroleum methods, petroleum exploration data sets, and petroleum exploration logic to help find more lead and zinc. It's been known certainly in the North Sea, for example, that lead and zinc has been discovered by the oil exploration drilling campaigns. So to summarize, I guess, it's very important that the metals explorers and the petroleum explorers talk and communicate and share knowledge and techniques a lot more than they currently do at the moment. And all three of our companies are obviously trying to assist and facilitate those discussions across the commodity